Like I've been trying to come online since like the 10th.
Yeah, we'll go ahead and get started. I did want to start with that IO. Woo, Denise, I think that may be you. There you go. Okay. I did want to start by reviewing some of the stuff that IO just mentioned. The times have changed now. If you were joining before at 10 or 2, the new times are 10:50 and 12:20. At 10:50, that is when the other doors teacher, Miss Wendy, is teaching. If you need to join in the morning, her Google Meet link, this is not for her, her Google Meet link is posted under classwork. Under the important class resources, there's one that says Google Meet links. If you click on that, that'll get you over to her time. Right there it is, Math Google Meet. And then the 12:20 time, that's, I mean, here I am. That's the time I'm teaching at. And you can, you can also get to the link from that document, or you can join using this link right here. The other thing I wanted to point out is we have posted under classwork the changes to tutoring. So under tutoring options, there's still the virtual tutoring option, which is via Google Meet, like it's always been, but the times have changed. So I've updated those in the description here. This now means that there's morning and afternoon times every day that you can join us for virtual tutoring. And there's the Google Meet link there. And then under in-person tutoring, this is where the form is at for you to sign up for an appointment to come in person for tutoring. We've got times every day in the morning and in the afternoon, and they're all within 30-minute blocks. If you feel like you need more than 30 minutes, you can always sign up for more than one appointment. You know, if you can sign up multiple times a week, if you want to come in multiple times a week for tutoring, but they all are in 30-minute blocks, and you can sign up for math, English, or Apex. So all that information's here. So I just wanted to say that again, in case you missed it on Thursday. We are starting Unit 2 today, which is all about linear equations, inequalities, and then something called a system. You all in pre-algebra saw a little bit about equations, a little bit about inequalities, so we're really going to be building on that knowledge you have from those topics back in pre-algebra, and then we're going to be introducing something called a system later on in this unit. Our objective today, though, for this introduction lesson is we are going to write expressions to estimate the cost of a pizza party. So the whole theme of this lesson has to do with a pizza party and how we can use what you guys already know about algebra to write these algebraic expressions. To start us off for our warm-up activity, we've got here some letters and what they represent. All costs are in dollars. So we've got M represents the cost of a main dish, N represents the number of side dishes, S represents the cost of a side dish, and T represents the total cost of a meal. Below, we've got 4 equations, and our goal is to determine what does each equation mean in this situation using these variables to help us out. I'm going to give you guys about a minute. You can either jot down your thoughts or just to think through them in your head. But go ahead, take a minute, see if you can figure out what each of these equations here are telling us. And then after a minute, we'll talk through it together. And Deborah and I'm going to bring you back. So let's talk through these 4 equations here and what we think they're telling us. This first one here, M equals, ooh, this is large. That first equation there, what is that telling us in this situation?
That's the cost of the main dish.
Mm-hmm. So give me a full sentence. Like, what is this here telling us?
So the it's telling us the cost of the main dish. So M is the main dish, and the cost is $7.50.
So we got the cost of a main dish is $7.50. Io, do you agree?
Yes.
Yeah. We know M is the cost of a main dish. We get the sentence here. What about this next one? M equals S plus 450.
So That is M is still the main dish based on the what we have, but that means M equals to the side dish plus $4.50. Maybe that's the tip. We don't know because it doesn't specify.
So we've got the cost of a main dish is equal to, you said S is what?
Side dish.
So the cost of a main dish is equal to, I'm going to say the cost of a side dish plus
$4.50.
So what does that mean if the cost of a main dish is equal to the cost of a side dish plus $4.50?
So which means the main dish up, which is $7.50, it's actually included with the side dish, I guess. Because it says the cost of the main dish is $7.50. And now the B part is telling us that to actually get the actual cost of a main dish, you have to add the side dish and $4.50. So which means the $7.50 we have up is the side dish plus $4.50, which gives us the $7.50.
So it's telling you another way to think of the cost of the main dish. So you're bringing in, we know that the cost of the main dish is $7.50. Another way you could describe the cost is the cost of that side dish plus $4.50. Io, were you thinking about it the same way in a slightly different way?
Yeah, I'm trying to figure it out.
This doesn't necessarily mean it's including a side, because remember, S isn't the thing itself. S is just the cost of a side dish. So this is just saying that our main dish is equal to the cost of a side dish plus $4.50. Another way you could think of it is whatever that main dish is, it's $4.50 more than the side dish. We could say the cost of a main dish is $4.50 more than the side dish. We've got that cost of the main dish is equal to that cost of the side dish plus $4.50. So if you add $4.50 to the side dish, that gives you the main dish. Lots of different ways you can talk through this. For C, Io, we haven't heard you yet. What is NS equals 6? What is that telling us?
And represent the number of side dishes, and S represent the cost of the side dishes. So it depends on it depends on how many side dishes she had or he.
Yeah, so it's I'm sorry, I cut you off. Keep going.
So that should be probably multiplication.
So you've noticed N is the number of side dishes. So we've got the number of side dishes. You said times what? Yeah.
Times
The
number of side dishes times the
N.
of cost of the side dish itself.
Dish equals what?
Number of side dish times cost of side dish equals to NS.
So finished what the equation's telling us. We've got NS equals 6. So this is saying when you take the number of side dishes times the cost of a side dish, it equals
to the main dish.
I'm looking at C right here.
Oh, C. Number of side dishes times cost of the side dish itself. Yeah, will give us the total cost of your meal.
Equals but I think you're trying
to the side dishes.
I think you guys are trying to get otherwise. Read the entire equation for me.
Oh, okay. NS equals 6.
Yeah.
NS, the number of side dishes times cost of side dishes will give us the cost, the price of the side dish, depending on the number. Yeah, they give us the price of the side dish depending on
which is 6. So you keep giving me words, which is great because you're describing 6, But we've got that $6 is, I heard you say the total cost of the side dishes.
Yeah.
When you multiply how many side dishes you're buying times the cost of each of them, you're getting $6. So this here is telling us that the total cost of the side dishes is $6. Then this last one here, we've got all the variables. We've got N.
Mhm.
I said N. We got M plus NS equals T. What's
That's
that equation they're telling us?
that's the main dish plus number of side dish equals to the total cost of your meal.
Equals the total cost of meal.
Of meal.
So we've got the main dish plus the side dishes equals the total cost of the meal. There's some words I could put in here to make it a little more precise. Remember, M doesn't represent main dish, it represents, come back to our definitions.
Cost of main dish.
So, main dish plus side dish times multiply number of
Yeah, so I could
side dish.
So I could put this right here, like I was saying, I could say the main dish plus the number of side dishes times the cost of the side dish. I'm going to go in here and I can't type today. The cost of a main dish plus, instead of side dishes, we've already said that NS represents the total cost of the side dishes. So we could say the cost of a main dish plus the total cost of the side dishes equals the total cost of the meal. Which makes sense, right? You're paying for the main dish, you're paying for the side dishes. So the cost of the main dish, the cost of the sides equals the total cost. This here is just a warm up. One of the things I wanted to emphasize here is looking at our equations. Do you see an equation that has some numbers and variables? So can I write an equation that's got both numbers and variables in it?
C.
Hello?
C.
Oh, yeah. Oh, I think you're answering in Spanish. C. Yes. Yeah. So C has is an equation that's got variables and numbers. B is also another example of that. Can you have an equation just with variables in it?
D.
Yeah, D is an example. This is an equation just with variables. And then we obviously know from before algebra, you can have equations just with numbers, right? Like 2 + 3 = 5. So equations can have a variety of information in them. It's just depending on what you're trying to describe. If I didn't know any information about these, you could still write this last equation here to describe the total cost of the meal, even without knowing the cost of anything. This is true no matter what the side dishes and the main dish cost. That's going to lead us nicely into what we're doing today, which remember we said the whole theme of today is planning this pizza party. So for this main activity we're going to be looking at, we are going to pretend that our class is having a pizza party. This is post-COVID. And together as a group, we're going to work to plan on what to order and estimate what the party is going to cost. I should emphasize here that this is one of those things where there are no correct answers, right? This lesson is going to really depend on what you guys end up wanting to do and what your estimates are. So with that said, let's go ahead and start the planning. If we're having a pizza party, we want to talk through what we plan on ordering, and we're going to estimate what that cost is going to be. If you guys want to have a pizza party, what's one thing that we need to plan on ordering?
The number of pizza.
Yeah, so we're going to need to order some pizzas. How many pizzas do you think we need to order?
For our class, maybe like 5.
5 pizzas?
Yes.
And then we want to get like an estimate for the cost. So we're going to estimate that it costs how much money for 5 pizzas?
That's if it's Little Caesar, that's like $27.
$27. What do you think about that first part? We're gonna order 5 pizzas for our pizza party, and we're thinking that's gonna be about $27.
Do we have a fixed price?
Ooh, tell us what you mean by that.
Like, how did she get it $27?
It's just an estimate. I just felt that if it's if we order from Little Caesar, that's a pepperoni pizza. That's like $5.45. So I just approximately estimated it to $27. So it's an assumed number. It's not really a fixed price.
And we got another pizza for like $35.
Well, that means I go cheap. That's why. So you might go expensive like Papa John's. So it will be more.
Do we want to change our estimate a little bit? We're good with 27, or you want us to go up a little bit?
Yeah, we can go up a little bit.
What do you want to change it to?
We don't want to go cheap, so let's go up a little bit.
I heard Io say 35. We want to do that? I should mention, I'm not asking you to contribute any money. It's just an estimate. So we've got 5 pizzas. Io, is there anything else you think we need to get for our pizza party?
Garlic bread.
Ooh, garlic bread. How much do we think that's going to cost?
That should be able to probably like $15.
$15. Okay. Anything else we need for our party?
A bottle of Pepsi.
Some Pepsi? Okay. How many Pepsis?
Yeah. Probably. No, one is okay.
1 Pepsi?
Yeah.
Is this a liter or a can?
Yeah. A liter.
A liter. I was like, is the 1 Pepsi for you? So 1 liter of Pepsi. How much do you think that's going to cost us?
Probably like $2. It should be like $2 or so.
$2.
Yeah.
Anything else we need?
We need some chicken.
Chicken?
Yeah.
Okay.
We need to have a party.
Yeah.
So it's not a party without chicken. Okay, so a chicken pizza party.
Yeah.
Tell me about the chicken.
We can order if it's just me, so we can have 10 pieces.
Okay, so 10 pieces of chicken.
Yeah.
And I'm gonna need you to give me a cost for that because I'm not sure.
That's like $14.
$14?
Yeah, before tax.
Okay.
Ooh.
So looking through this, I'm gonna add in some of our numbers. So for the 5 pizzas, if we're estimating that $35 is the total of 5 pizzas. Is that right?
Yeah.
Yeah.
Okay, so then I'm just gonna put down. So then 1 pizza we're saying costs like $7 then, and there's a total of $35 for the pizza. Garlic bread is at $15 for all the garlic bread, for 1 order of garlic bread.
Oh.
For all of it? Is that what I heard?
Yeah.
Okay, so that's a total. And then this one we're saying 1 liter is $2, and it's also a total of $2. And then our chicken, 10 pieces, is $14. Okay. I think this is a good party. We've got a good amount of food for our party. So I'm gonna have us come down here. The next part of this is we're gonna write down expressions that show how your group cost estimate was calculated. So if I'm trying to figure out how much total money this party costs us, what calculations would I need to do? When it says expressions, notice that's not an answer. It's just a way to show what math we would need to do to find the total. Addition. What am I going to add?
Add it, the total amount of pizza, garlic bread, Pepsi, and the 10 chickens. It's all together.
So tell me exactly what I want to write.
35 plus 15
35
plus 2 plus 14.
So that's going to give us our
total amount of money spent.
Ooh, thank you for giving me that nice precise description. So total amount of money spent. Okay. So we could go ahead and add it up. If we've got 35 plus 15, 2 plus 14, what's that going to end up giving us?
$66.
So we get our total amount of money spent. Okay. So to throw this party, it costs us $66. That's what we're anticipating. Now, when it comes to our pizza party, the day of the pizza party, in this equation here, are there any quantities you think that might change on the day of the party?
Yes.
Why is that?
Depending on the turn up. Now, this is basically based on probably few students. So if we have a larger number of students turning up, then we have to increase the purchase for everything.
Yeah. So if there's a lot of people who came out, we might, instead of 5 pizzas, need to buy more pizzas. Maybe this 1 liter here, I've already had a question mark by. If we had a lot of people, we might need more soda. So you're saying like across the board, we might need to order more of everything. So we're saying, depending on the turnout, there may be more people. And if so, we need to order more of all the food items so that the amount would change, the amount of each of those items. Is there anything else that we think might change on the day of the party?
The price, the total cost.
The total cost?
The total amount of money spent will change. Because if we increase the purchase of everything, then the amount will change as well.
Yeah, that's a good point. So our total amount spent could change. Right. If we changed any of these numbers here, then that total amount could change. So we're saying we're estimating it's going to be $66, but if it turns out we have more people there and we need to buy an extra liter of soda, then that amount, the total spent, is changed. Anything else we want to identify as something that might change? Io, do you have anything in your head?
No, I'm okay with it.
We're okay with these 2 things? Okay. So then this last part here is that expression we had earlier. This was based on these numbers we had come up with, but we're saying that some things could change. We are going to rewrite that expression and we're going to replace those quantities that might change with letters. You guys have seen this before. We're using variables. When you use those letters, we're going to describe what it stands for. So I'm coming back here I'm going to copy. Oh no, I put it in a bunch of different boxes. Okay. So these were all the different things we had said earlier. We said each pizza $7, so that's a total of $35. The garlic bread is $15. 1 Pepsi is $2, and then our 10 pieces of chicken is $14. That's where this equation here came from. We are going to rewrite this using variables for any value we said that might change the day of. So keeping that in mind, how could we write our expression? So
it's going to be okay, we're going to have P plus B plus let's use M to represent the pizza.
P plus B
plus M. We just use M for the then plus C equals T.
Equals T. Okay, so you gave us a lot of letters. So P you're saying is?
The pizza.
Specifically, what about the pizza?
The price of pizza.
The price of pizza. When you say price of pizza, can you be even more specific?
Yeah, the total cost of pizza.
There you go. So I'm going to put in here the total price of the pizza. Now we said earlier, why would that change?
We said depending on the number of pizza we ordered.
Yeah. So we had said if there's more people who are coming, we might need more pizza. Less people come, less pizza. If we had looked it up today and saw that one pizza costs $7, do we think that cost of one pizza is going to change? Like you said earlier, you mentioned like Papa John's. Let's say Papa John says each cheese pizza costs $7. If that's what their website says today, if we hold this pizza party next week, do you think that price will change?
Yes, it's subject to change.
Tell me why.
Yeah, just like we said, the number of pizza ordered depends on the amount that we'll pay, and also it depends on where we order the pizza from, because each pizza joint had different prices. So the price is subject to, number one, where the pizza is being ordered from, and then two, the total pizza ordered.
So let's make a decision then. Io left us. So it's just you and me, Deborah. Let's make a decision. Let's say we are for sure, I heard you mention Little Caesars. So we are for sure going to go with Little Caesars pizza. Okay. And it sounds like you know better than I do. How much does Little Caesars pizza cost? Is it $5?
Some 5, some 6. So let's go with the 5.45.
The 5.45. Okay. Yeah. So we for sure know this price. That price isn't going to change. What you had identified earlier is the amount of pizza we order is going to change. So we could use P, the total price of our pizza, as our variable. There's something different we could do. You said that pizza is $5.45 for one pizza. How else could I represent the total price of pizza?
Sure. Okay. Again.
So you said one pizza costs $5.45.
Okay.
But we've said we are going to need more than one pizza. How else could you represent the total price of all the pizza we buy? You've got P is one way. We could just call the total price P. Or there's another thing we could do.
Oh, okay. Can we say can we use TP?
Oh, yeah. What would that be? TP?
That would be total price of pizza.
Okay. So if we're using two letters, that means two variables. It means there's two things there we don't know. Okay. So if we write TP, that means T needs to represent something and P needs to represent something. You had given me this number earlier. There's a way we could write an expression using this number. If we know for sure, we've decided beforehand, we're going with Little Caesars Pizza. Their pizza costs $5.45. We said we're going to buy multiple pizzas. What would you have to do to find the cost of multiple pizzas?
Oh, okay. So that would be 5.45 multiplied by N, the unknown number.
There you go. So we could also write 5.45 N. Yeah. You said N is that unknown number. Mm-hmm. How could we describe N?
N is the number of pizza ordered.
Yeah, number of pizzas ordered. So depending on the information we know, right, you can come up with different expressions. We originally said P, and that works, right? This is showing us how we calculate that total cost. P is going to be that total price of pizza. But if there's some information, like if we know the cost of the pizza, earlier we had estimated it would be $7, so we could use 7 there instead. This is another way you could represent that cost of the pizza. We could write P, or we could write 545 N, where N is how many pizzas we're ordering. That way it's still including that unknown. We had said earlier, we're not sure how many we're going to need that because it depends on how many people come that day. It's just another way to represent this unknown amount. So we said P was the total price of pizza. We said B is going to be the cost of the breadsticks.
Mm-hmm.
The total cost of breadsticks. So we could leave that as B if we wanted to use that estimate we had. Io had told us an order of breadsticks, or I'm sorry, I said breadsticks. An order of garlic bread costs $15. Do we think how much garlic bread we're going to be buying is changing at all?
If it costs $15, that's like how many would that be? I know they have like a pack of 7 in one. So that's like we're talking about 3 packs.
Okay. So then if we wanted to write it similar to how we did this first part, the 545N, what would that look like?
It's going to be 15. I don't want us to use hen again.
I agree.
Yeah, 15x.
15x. Okay, and then X represents?
X represents the number of garlic bread ordered.
Yeah. Bread ordered. Okay. So if garlic bread one order costs $15, this here is telling us $15 times however many we order. Maybe we know that we're only going to order 1 garlic bread no matter how many people come or how little come, then we wouldn't need that variable. We could just say plus 15. For M and B, let's wrap this up real quick. I'm going too high. M was that our soda?
Yeah.
So M represents that total cost of soda. And then the C was, I remember, the total cost
of chicken.
Of the chicken. So similar to all of these, we could keep representing them with those numbers there, or this one equation here that's got no numbers, all variables, but it's still telling us how we would find that total cost there. So that if on the day something changed here, we would be able to make those changes in our equation.
Okay.
These are all examples of something we call mathematical models. In pre-algebra, we explored a lot of different mathematical models with like equations, tables, graphs. All of these different mathematical models we have are just different ways you can represent situations in life to help us make sense of problems and solve them. If we had an equation with these numbers in here, let's say the day of, I know I'm going to buy 4 pizzas instead of 5, you're able to represent our total cost using variables when they're unknown, and then we would be able to solve for the cost once we know them. When we talk about equations and variables like these, there's something else we can talk about called a constraint. Do you know what a constraint is?
Constraint is like something that holds you back, like it causes you to pause. So that's just the literal meaning.
When you say like something that's holding you back, I'm thinking like restricting. It's like something, it's a restriction of something. I keep seeing you like go in and out. So I'm wondering if you have technology questions, but I'm not trying to ignore you. So do you have anything to add? Have you heard of the word constraint before?
No.
Okay.
Yeah, something that stops you or holds you back.
In math, a constraint is something that limits what is possible or reasonable in a situation. So an example for our pizza party. One example could be one constraint in the pizza party might be the number of slices of pizza each person could have, which we'll call S. If we write S is less than 4, that's saying that each person gets fewer than 4 slices. So we were calculating it by like how many pizzas we were buying. Maybe someone else would have said, okay, like I think about 2 slices per person. We'll just say that a constraint is no one can have more than 2 slices. And once we make that constraint, then we could do the math afterwards. That's an example of a constraint, is you're limiting what is possible or reasonable for a situation. So coming back to the expressions we wrote earlier for our pizza planning, we're going to choose an expression that uses one or more of our variables. And for each of those variables, determine what values would be reasonable. So for instance, could the value be a non-whole number? What does that mean, a non-whole number?
That means decimal.
Yeah, so whole numbers are those numbers you count by, 1, 2, 3. So non-whole number would be like a decimal or a fraction. That's something you can think of as a restraint. So when we said up here that the slices of pizza, S is less than 4, S also needs to be a positive number, right? You can't have -3 pizza slices. So that's another example of a constraint. So you think about, could it be a non-whole number? Could it be a number greater than 50? A negative number? Could it be exactly 2? So we're going to go back to our expression you wrote earlier, and we're going to think about what constraints there are on those variables you identified. I'm going to come up. I'm going to use this equation here. So this is the one we're choosing. Whoops, I don't know why I went down there. Okay. So for each one of these variables, we want to determine what values could be reasonable. For P, we had said that P was the total cost of the pizzas. What values could be reasonable for P?
Is it? I didn't. Is it the cost of the pizza? Do you want us to come up with a different value than the one we had before?
Nope, we're just talking about what's reasonable. So when we say P represents the total cost of pizzas, what numbers are reasonable for P? So for example, could P be greater than 50? Could it be a negative number? So we're going to describe what type of numbers P could be.
P has to be a positive number.
Yeah.
It can't be negative.
Woo, things popping up on my screen. Okay, yeah, so P has to be a positive number. God, I can't type. Positive number. You said it can't be negative. Why can't it be negative?
Because we are paying for the pizza. No pizza Little Caesar will not sell on they will not sell on debt and allow you to owe them. You have to pay before you pick the pizza up.
Yeah. So there's a way for us to write P has to be a positive number using an inequality. We want to say P has to be a positive number. How could we use that using a less than or a greater than sign?
P is we use greater than.
Mm-hmm. P is greater than what?
Greater than 30 or 35.
Okay.
But less than 50.
Okay.
Yeah.
And P is less than 50. Okay, so just like that, you made constraints for P. You said that P has to be greater than 30. You're saying we're going to spend more than $30 on pizza. Mm-hmm. But what's the second part saying?
It has to be less than $50. You can't go above $50.
So you're giving yourself a budget. You're giving yourself a range here. When we say P has to be a positive number, you can represent just that description with an inequality. If P is positive, it means P is greater than what number? Forget pizzas for a second. If P is a positive number, it means it needs to be greater than what number on our number line?
Greater than 0.
Yeah. So if you're trying to say your variable has to be positive, a constraint you could say is that P is greater than 0. So this example we had earlier with the slices of pizza, S is less than 4. We could have also said S, the slices, needs to be greater than 0 because you have to have like a positive number of slices. It can't be negative. You went a little more specific though, Deborah. You said we're going to spend between $30 and $50 on that pizza. So we're saying P is greater than 30 and P is less than 50. I'll help me with our soda. You said M, we said represented the total cost of soda. M equals the total cost of soda. Give me a constraint for M.
Okay. M is equals to
we said earlier, M is the cost of the soda for our estimates. We said each liter was $2.
So
I can say M is.
Can I use less than?
You can.
Okay. M is less than the cost of the pizza.
Ooh. So you're what? So tell me what this is saying. If we say M is less than the total cost of the pizza, what does that mean in this situation?
As it's smaller than the cost of pizza.
Yeah. It means that total cost of the soda is less than the total cost of the pizza. It means you're going to spend more on pizza than you're spending on soda. You do not want to spend all your money on Pepsi and not get any pizza. That's another example of a constraint. That's nice. Deborah, I think you were going to say something too. What were you going to say?
Now, when we talk about the constraint on the soda, we can say what do we use in representing the soda? M. Okay. M is greater than 0, but less than, and M is also less than 3, based on the price we have up there.
So yeah, so you're saying that cost we're going to spend between $0 to $3.
Yeah.
You can also use an equal sign. So earlier, Io said, we're going to spend a total of $2 on soda. I don't care how many people come. Like, that's what we are going to spend. If it's not in a range, if we're not trying to say like less than or greater than, you can say for your constraint that M equals 2. That is, I'm not spending any more on soda. I'm not spending any less on soda. I'm spending exactly $2. So your constraints can use inequality signs or they can use equal signs. It's whatever the situation calls for. To help us kind of wrap up here, there's 2 major things we were focusing in on. We wanted to focus on this idea of writing these expressions and equations with variables and talk about this idea of a constraint. In planning this pizza party, what were some ways we gathered information to estimate the cost? When you guys were giving me these numbers, where were these numbers coming from?
From the cost of pizza.
Yeah, how did you know that?
Oh, because I'm a regular, at least.
So I'm going to write past experience, right?
Yeah.
Do you think that our estimate would have been different if we did some research?
Yeah.
For sure. So we could have done research and come up with a different estimate, past experience. You broke out that number 545, Deborah. Like you had Little Caesars memorized. So depending on the people we're talking to and their past experience or research, there's a lot of different ways you can get this information to help you estimate. Now, in doing so, especially since we didn't do any research, some assumptions were made. What were some assumptions we made in doing this estimation here?
Well, we assumed the price because that's not the exact price. So
yeah. I'm scrolling all over.
for all the items, they were all assumed price because we are not actually in the store to buy them.
Yeah. What's something else we assumed? When we
Pepsi, everything.
We assumed the number of people that will be coming as well.
Yeah.
Number of people. So we assumed the price of each item because we didn't do any research. We assumed how many people were coming that day. Anything else we assumed?
We assumed the quantity of pizza everybody or the get to eat.
We assumed, yes, definitely. How much?
A whole box, so don't assume I will eat just so that might mess up the party.
Yeah. So suppose then we made a different set of assumptions. So for instance, assuming that this is talking about like the type of pizza, but you said like we're assuming how much everyone will eat or drink. What if we assumed differently and we assumed no one who came to our party was really hungry and we assumed that they're only going to eat like a little food? How would that have changed our cost estimate then?
Our list is gonna be like the price is gonna be little like the pizza is not gonna be like $35, probably like $20.
Yeah, so you're going back to those constraints though. You said that there are constraints here, the 30, it would be less than 30. It would impact the cost though, right? Lots of times when you're writing these mathematical models, here there's some assumptions that have to be made when it comes to them. So you're pulling out that if we assume something different, we assumed all our guests aren't that hungry, it's going to impact those constraints and the amount of money we're spending on each of those items and the total amount of money we're spending. That is where this lesson kind of ends for today. This is like, it's a warm up for where the rest of this unit's going. Tomorrow, we're going to be looking a lot more at equations and variables and how you can represent scenarios using those. But this was to get you guys all warmed up, and you did great today. I don't think it was this class. I think it was a different class last week. But they said, like, what's happened to algebra? Like, we're doing a bunch of statistics. Where are the equations and the variables? And they're back. So I don't know if you missed them, but they missed you.
I don't miss them.
Yeah, right.
I love the statistics more.
Well, it makes me happy you love statistics so much. There's room in your heart, though, for you to love this as well.
Yeah, statistics, you just need data representation. So, and that's it. You just get going. So you could just plot your histogram, do your dot plot, and just get going. You don't need some calculation, basically. And they are pretty easy. But algebra, well, I have to fall in love with it again.
Yeah, you just need to observe the dots and know the names of the holograms.
Yeah, for algebra, it's gonna be a fruitful marriage. Well, before too long.
We'll get you there. I love statistics too, but I also love algebra. So it's just a matter of time. You'll come over to my side.
Okay. I hope so.
Well, that is all I had for you guys. I hope you have a wonderful day, and I'll see you tomorrow.
All right.
Thank you.
Have a good day.
Have a good day, Miss Denise.
You too. Bye-bye.